right, welcome back. Okay, we're going to do some practice problems on the Ionic bonds multivalent practice, a handout that you received today after the notes that you took over multivalent practice, multivalent bonds. Now, if you don't remember what they are, go back to that first video and then you can start on this one. Now, I'm going to read the background here, and it says, the charge of the ions of some elements can easily be predicted from their position in the periodic table. For example, calcium loses 2 electrons to form a +2 ion. Chlorine atoms gain 1 electron to form 1 ion, -1 ion, sorry. Other elements are more difficult to predict and may even have different charges. An example is copper atom that may lose either 1 or 2 electrons. The charges of the ions of an ionic compound must add up to 0. The number of electrons lost must equal the number of electrons gained. Now this typically happens with a transition metal, tin or lead. So I'm going to write that at the top right here. I'm going to write need Roman numbers in names of formulas containing transition metals and these aren't transition metals, but they're part of it. Tin and lead. Okay? So you'll always need your transition numbers. Whenever you have transition metals, Roman numerals, you'll always need your Roman numerals when you have transition metals, tin or lead, in your formulas. Just to remind ourselves, this is a 1, 2, 3, and the last one would be 4. Okay? If you have to write them up there, it doesn't matter. There's no shame. Okay? As long as you get it right. Okay, so on this first one, part A, it says to write the charge of the metal. I just want the charge of the metal by itself. Okay? In the compound on the line. Assume that the charge of the halogens is a -1. Oxygen and sulfur are always going to be a -2. And nitrides are going to be -3. Where the heck did they get these numbers from? Well, it is from the periodic table that we filled in yesterday, or in the other video. The +1, 2 plus, 3 plus, 4 plus or minus, -3 negative, 2 negative, and 1 negative. These are your oxidation numbers. Okay, that's where they got it from. They're just giving it to you ahead of time so that you can fill this out easier. All right, so we're going to start off with 1A. 1A is telling me that I have CuCl. Cu and Cl. So we need to look up the names for Cu if you don't remember them. Cu is copper. Cl is chlorine. So I'm going to write this down. Oops. Here it goes. On your copper, I'm going to write, well, I'm going to put it on this paper. Chlorine, which is a halogen, is going to be a -1. Now, mind you, if there's no subscripts, you're always going to think this. Same number, opposite charges. No subscripts, same number, opposite charges. I know for a fact that chlorine is a -1. So that must mean that my copper was the same number opposite charge. So the same number is a 1. the opposite charge of a negative sign is a plus sign. So your metals will always be your cations that are positively cute, and then your anions will always be your negative. So on this line, it wants the charge of the metal ion, so that means I'm going to write down a +1. And that's it. Let's go on to the next one. Oops. I'm looking at SNO, SNO. And again, notice that we're in the same predicament in which there's no subscripts in it. No subscripts. We know that oxygen is a -2. And again, since there are no subscripts, that means that they were the same number opposite charges. Same number meaning that they're both a 2. Opposite charge meaning that instead of a negative, it was a positive, because metals are cations, positively cute. Oxygen is a negative, okay? So don't forget that. And again, we just want the charge of the metal, so I'm going to write down +2. All right, let's go on to 7A. All right, so 7A says Hg. And in this case, it has a subscript of a 2, S. All right, so in this case, we're going to do what is called the reverse crisscross. Reverse crisscross means that I'm going to reverse our subscripts. So remember how I told you if it was a 1 that you didn't have to write it? Well, now I'm going to place it here so that you can see what happens. So reverse crisscross means that the subscript of my anion or my nonmetal came from my metal, so that means I had it right here. The subscript of my metal came from my nonmetal, so that means this one came from up here. Again, your nonmetal is a negatively charged, and your metal's charge will always be positive. And so what we're going to do next is just write down the oxidation number of our metal, which would be our +1. Okay? Again, practice makes perfect, so that's why we're practicing. Now, what we're going to practice next is actually writing the names. So let's write the name of the first one. So 1A goes with 1B. So 1A is Cu. We know that Cu off the periodic table is a transition metal. So that means I have to write a Roman numeral with this. So I'm going to put down copper. Okay, that's the name of our metal. Write down the name of your metal. Next, you're going to put a Roman numeral. Now, that is the oxidation number, and if you notice right here, we wrote those down. So our metal was a +1, so we're going to put the Roman numeral 1 right after our metal name. Okay, I go on to my anion, or my nonmetal. It is Cl. And if we look that up on the periodic table, that is chlorine. Now, before I write the nonmetal down, or my anion, I have to, I'm going to take these away, so get them out of the way. There we go. I have to remember, whenever we're making a formula, writing out a formula, we're going to drop the ending of our anion. So in this case, we're dropping the INE, and we add IDE. That means we have a formula that we created a compound. So it's going to be copper 1 and then chloride. Okay, let's do another one. We're going to do 4A, which is, move this out of the way, 4B. Okay, so this one goes with this one. So I'm looking at SN. If I look for SN on the periodic table, SN is not part of the transition numbers, but metals, but again, it has those rules set with it. So again, since it's tin and lead, these two are going to have the same rules as the transition metals. They are going to need a Roman numeral. So I'm just going to say, again, this is 10, and we said that this was a +2. Okay, so let me write down 10 first. Oops, I'm writing out 10. Excuse me. 10. And we're also going to put that it is a +2, so Roman numeral 2. Let me get the 10 out of the way. So write a 2. And then I'm going to write the ending, which is O, and you better know that O is for oxygen. And oxygen is one of those weird nonmetals that it's the last 4 letters that you're going to drop. So instead of oxygen, we're going to put oxide. So it's going to be 10 oxide. Again, sorry. All right, one more, and we'll call it a night. Last one we're going to do is 7A, so we're looking at 7B. 7B, we're going to start off with Hg. And if we look on the periodic table, Hg is part of the transition metals. It's right here. So we do need a Roman numeral. So mercury. And we said mercury was a +1 oxidation number. So that means it's going to be mercury 1. And we'll write that down. And mercury 1, and then what's the ending going to be? S. S is for sulfur. And again, the Roman numeral only pertains to transition metals, tin and lead. So we just write down, we're going to put down sulfur. Now again, since we are creating a formula, we need to make sure that everybody knows it, and so that means I have to drop the ending and add IDE. So sulfur is going to be sulfide. There we go, sulfide. Okay, so that's going to be that section. And then the last part is down here. It wants you to, first you're going to write down the actual oxidation numbers with the symbols. So iron, if we look for iron, iron is right here in transition metals, okay, Fe. And again, the Roman numeral tells you what its oxidation number is. So since it's just a Roman numeral 3, I'm going to put a +3 at the top. Chloride means it is chlorine, and that is Cl. And according to the periodic table again, chlorine is a 1 negative sign, oxidation number, sorry. So +1, -1, or 1 minus 1 plus is the same thing, so you don't have to worry about that. All right, so are they the same number opposite charges? No. So again, I'm just going to write it right here so that you can see what we're doing and what happens to these lovely charges and numbers. I'm going to put 1 negative here. Since it is not the same number opposite charges, you get rid of the charge itself. It disappears. You no longer need it for anything. And now we're going to actually crisscross. So that means I'm going to write my metal first. The superscript from the anion will become the subscript of our metal. Since it is a 1, I don't have to write it. So now I'm going to write down my nonmetal. The superscript of or the oxidation number without the charge of our metal becomes the subscript of our nonmetal. It also tells you to make sure that it's the lowest ratio. So 1 and 3, that's as far as I can go. All right, let's do one more here. I'm going to do one that's a little bit more difficult, and that is going to be the next one. Well, not more difficult, it's just an extra step. So 10, 4, so I'm going to write 10. Okay, that's the formula, or the symbol, sorry. And it has an oxidation number of a +4. Okay, remember, the Roman numerals go with the metals. Roman numerals, metals. And then oxide is going to be O. And that will always be a -2. Let me flip this over. So Sn +4 O -2. Are they the same number opposite charges? No. So let's get rid of the charge. Again, I'm going to write my metal first. And then the oxidation number without the charge of the anion or the nonmetal becomes the subscript of my metal. So this time I'm going to put a 2. So that goes across and becomes a subscript. And then the nonmetal will get the oxidation number without the charge of the metal and have it as a subscript. So this goes straight across. Next, I'm going to look. Well, this is a 2 and this is a 4. Is that the lowest ratio? No. So therefore, I'm going to create the lowest ratio, and it should be SN O 2. Okay, that's what they mean by lowest ratio. You're just making it to the least of it. So since this was a 2, this was a 4, it becomes a SN1O2. Okay. Now, your turn to practice on your own. If you have any questions, please feel free to ask, okay? Thank you.